Okay, so back for the second part of the numeric variables lecture. So, first thing to note is the way the syntax works. The standard assignment syntax is you put the variable on the left and the expression on the right. So, you get the name of some variable equal to the value of some expression. When you do that, you fully calculate the expression, so everything on the right goes through, and the final result of that gets assigned to the variable. For example, you can go here and create a new little bit of sample code, call it fun with numbers 3. Go ahead and do this. And in our main method, we can do something simple like int x equals. So that's the variable. Over here we have x. We've declared it as type int. And whatever we want to call it, we can put here on the side. So we can have just a plain number, just a single literal constant. We can have some mathematical formula, like 6 times arithmetic formula. Or we could even use a pre-existing variable. So like int value equals 6, and then x equals, say, value times 6. Any of those would be perfectly fine. So you calculate the value of the expression on the right, and the final result of that you assign to as the value of x. Okay. Other things, there are implicit operator statements. So this first one here, x plus equals 1, that simply means add 1 to x, add 1 to itself. Minus equals 2, subtract 2 from x. Times equals 3, we multiply x itself by 3. Divide equals 4, we divide x by 4. And x modulo equals 5, we assign the value of x modulo 5. So these are all simple things we can print out. So if I say, for example, do int x equals 0, and then x plus equals 1, system.out.println x. We will start off with x equaling 0. We'll add 1 to x, and then we can print it out. So we run that. And x is 1, no surprise. If we want to multiply it through by 2, x times equals 2, then we'll just turn it into 2. And if we like, we can do similar, keep on doing it indefinitely. So x times equals 4. So here we'll add 1 to x itself, then the new value of x will multiply that by 2, and then the new value following that of x will multiply through by 4. So in the end, we'll have 8 if we run this. Ta-da! Okay. Also, increment, decrement, you do plus plus for adding 1 to x, or x minus minus for subtracting 1 from x. So, for example, following this, remember at this point x is 8. After this statement, if we like, we could add 1 to x, make it 9, or we could subtract 1 from x and make it 7. Okay. Now again, none of this that we're doing here is especially useful. We're just demonstrating the syntax. Okay. So, next thing, arithmetic expressions. So mostly in Java, arithmetic expressions are calculated the way you're used to, the way you'd expect. But there is one big quirk, and the big quirk is this. Dividing an integer type by another integer type always results in an integer. And in particular, fractions are dropped, not rounded. So, if you take this calculation, do x equals 3 divided by 2. In the real world, 3 divided by 2 would be 1.5. But in Java, 3 divided by 2, you drop the fraction because they're both integer types. So, it becomes 1. Likewise, the second one, int x equals negative 3 divided by 2. In the real world, it would be negative 3 or negative 1.5. But of course, in Java, you drop the fractional part, so it's simply negative 1. Okay, modulo returns the remainder from division. This isn't a quirk. This is just the way modulo works in any sort of mathematical situation. So, for example, if you divide 12 by 7, the result is 1 with a remainder of 5. So 12 modulo 7 resolves to 5. Likewise, if you take a decimal value, for example, you do 6.0 modulo what? Let's say 2.4. Okay? Equals what? Well, if we divide through, we get 2 with a remainder of 1.2. So 6 modulo 2.4 is 1.2. Many people fail to remember. They'll say, oh, 6 divided by 2.4, that's 2.5. So the answer would be 0.5. Not true. Okay, it won't be 0.5. Like I said, it'll be the actual numeric remainder, not the fractional part. So 6 modulo 2.4 is 2 with a remainder of 1.2. So it evaluates to 1.2. Okay. Now, order of operations. Order of operations you'll see in Java are basically the same as what you've seen in algebra way back whenever you took that. So, first of all, expressions in parentheses are evaluated first, starting with the most deeply nested. So if you have a pair of parentheses inside another pair of parentheses, you evaluate the inner pair first. Second, there are 3 operations that are called multiplicative. They're multiplying, dividing, and modulo. And anytime those appear, they happen before additive operations, as long as they're, within the same level of the parentheses. And after that, left to right. So if you have a multiplier and a divider and a modulo operator, if you have those 3, you just do them in the order they appear in the calculation. So left to right. Let's go through some examples. So over here, the first one, we have a multiplication, we have a subtraction, we have a division. Well, multiplication and division are both multiplicative, so those get calculated first. So 5 times 3 is 15. 6 divided by 2 is 3. So we go 15 minus 3 equals, and we do the subtraction, equals 12. Likewise, the second one, we do the inner parentheses first. So we have 5 times negative 3 divided by 2. Well, then we have multiplication and division, so we just do those left to right. So we get 15, negative 15 rather, divided by 2 equals negative 7.5. But of course in Java, we drop the fractional part, we drop the decimal part because they're both integers, so it becomes negative 7. Last one. So there are parentheses, we calculate what's in the parentheses first, and we have a division and a subtraction, so we do the division first. So this one is going to equal 5 times 3 minus 3. We do the 6 divided by 2 first. Then we do the parentheses, resolve that. 5 times 0, which of course equals 0. Easy. Okay. Next thing, returning primitives. So any of the primitive types that we've covered, right? The 6 numeric types, plus Boolean, plus char, which we haven't covered yet. Any of those can be returned by a method. You just show that the return type in the method has that type, and you can return that value. So again, you can either return a literal value or the variable. For example, instead of return 6 here, I could do return x. That would be fine. Or I can return a more complicated arithmetic or other expression that resolves to an int. So here, x is an int with the value of 6. I'm returning the value of x times 5, which is 30, so the method would return 30. Other thing we'll talk about in a minute, the return type has to be compatible with the actual value. What basically that means is we can't have send along a number where we lose data. For example, if this number sends along an int, I can't have double x equals 6.5. Reason is, if I try to return x, I'm not going to be able to return 6.5. It's going to send back an integer. I'm going to have to do something about this 0.5. We'll talk about that shortly. So, 2 different kinds of typecasting. So typecasting is a generic term in Java for converting one type to another. And with numeric variables, it's typically used for changing number formats. For example, you want to use a numeric type that takes up less memory, or sometimes you'll use it for just matching the kinds of variables that are used in an inheritance hierarchy. So your superclass uses one kind of variable, so you cast another variable to that same type so you can do the same thing. Anyway, when you are typecasting a variable, what you want to do is put the type that you want it to be in parentheses in front of the number. For example, if I want to turn this 23, which is by default an int, if I want to turn it to a double, I could typecast it by putting double in front of it. Now, Java has an assumption that if you have literal numbers without any other identifiers on them, if it's a floating point number, it'll be considered to be a double. And if it's an integer, it will be considered an int. The exception is if it's used in a valid lower precision argument. For example, a byte can hold a value from negative 128 to positive 127. So 23 is absolutely acceptable. And Java, the IDE, will say, okay, that's 23. You can put that as a byte. However, if I try to assign byte b equals 5 times 100, 500 is too large to be stored in a byte. It won't let you do that. I can demo that here in Java. So let's do byte b equals 23. Perfectly fine. No error. But if I do b equals 5 times 100, I get the error in the margin here, and it'll say, cannot convert from int to byte. And the simple reason is the range of byte values contained in an int, or potentially contained in an int, is so much larger than the ones contained in a byte. Byte can't hold them all. So I would have to lose data. And anytime you lose data, Java's going to fight back and say, nope, you can't do it that way. Okay. So precision. Precision is an idea that basically includes the wideness of how many values a number can hold, numeric variable type can hold. So all of these 6 numeric types in Java have a precision order. Now, in everyday use, precision means accuracy. Well, it's not exactly that here. In Java, basically precision means being able to store bigger numbers. So almost exactly every number that can be expressed by a lower precision type can be expressed by a higher precision type. For example, clearly every number that could be in a byte could be in a short, right? Short obviously encompasses the entire much smaller byte range. Likewise, int encompasses the entire much smaller short range. Long encompasses the much smaller int range. Now with float, things get a little tricky with float because although float can hold a larger range of numbers, it doesn't have as many potentially it doesn't have as many decimal places as a long. A float only holds out numbers 8 digits long. So if you get a big number like you would have in the higher end of a long, something like 10 to the 18th, 10 to the 17th, say 10 to the 18th, whatever, a quintillion, you won't be able to represent that exactly as a float. But the assumption is if you're dealing with numbers that large and you have a float, you're willing to sacrifice that precision. Likewise, every value stored by a double can be, any value stored by a float rather can be stored in a double. But double even, again, has the same problem. It can't hold quite as many digits as a long. So if a long is a very, very large number, if you try to express it as a double, yeah, you might lose a 1 decimal place of accuracy in your scientific notation. But still, Java assumes that more or less any number that can be a long can be represented as a float. And it is true that any number that can be expressed as a float can be expressed exactly as a double. Okay. So let's go back. Okay. So that's precision. So the precision order, all floating point types are considered to outrank all integer types. And within floating point types, double outranks float. And within integer types, long outranks int outranks short outranks byte. Okay, well, what does that mean? Well, when we're doing typecasting, there are 2 ways that it can happen: promotion or demotion. So in Java, it's legal to promote any lower precision type to a higher precision type. Okay, you can do it explicitly, like the example we had before, where say double x equals double 1. In this case, 1 would be converted to 1.0 and assigned to x. But since you generally do not lose any data when you're promoting, Java doesn't make a big fuss about it. So even if you just write it as this, double x equals 1, the IDEs automatically can store 1 as 1.0 in the variable x. Okay, you don't actually have to write it. That's implicit typecasting. And besides assignments, promotion works in other things, such as returning values for methods. So, if you had, let's see if we didn't have that. Suppose you have a method that wants to return a double. Okay, double method and doesn't accept anything. If I want to return 6.0, well, 6.0 is a double, and that's obviously fine. But I can also return 6. I can return an int type because Java will automatically convert that int to a double. There's no loss of data. Okay? On the other hand, if I want to return 6.5, right, Java doesn't like that. We'll say, oh, if you want to try to return 6.5 as an int, you're going to lose some data. So we got to do something about that. Okay. Other places where this works, if you have intermediate calculations in arithmetic expressions. We'll talk about that on the next slide. And sending arguments to methods. So, for example, suppose this method accepts a double x. Right? Let's say it returns a double and accepts an int. Well, let's say it accepts a double. We'll leave it as it was. Okay? And I want to call this method. So I'll say make a new object. And I'll call it fwn3.method. And I'll send along a value 5. This does not present a problem because 5 is an integer. When that argument gets sent to this method, then it just converts 5 to 5.0 because x is a double. So there's no problem as long as you're promoting. You generally don't lose data, and so Java doesn't worry too much about that. Okay, so we'll talk about mixed expressions. A mixed expression in Java is one that contains more than one numeric type. So when you're evaluating mixed expressions, what happens? Well, promotion gets applied to any result. Anytime you do a calculation in Java, if there's a mixed expression, if there are two different numeric types, the result is the type with the highest precision. So, for example, here we have a sequence of addition, 3 plus 2.0 plus 3, all just goes left to right. Well, the first calculation I do is 3 plus 2.0, right? So Java, you don't do all this, you don't do all three calculations in a set. You do first this, and then add 3 to that total. So 3 plus 2.0 is a mixed expression, so the result will be of type double. So we get, that's equivalent to 5.0 plus 3. And then this is again a mixed expression, so the result will be a double. It'll be 8.0. Second one, we have a division, so division happens before the addition. 3 divided by 2.0, well, the result is going to be in type double because the 2.0 is a double. So that becomes 1.5. We add 1.5 to 3, we get 4.5. Okay? Again, this 1.5 plus 3 is also a mixed expression. However, right, this expression, 3 divided by 2 plus 3.0, division happens first. In this case, the numbers are both integers. So if we do that division through, we get a result of 1. Add 1 then to 3.0, that's a mixed expression. 1 plus 3.0 is 4.0. So, mixed expressions, if they involve two different types, the result is always of the higher precision type. Okay, last thing, DMotion. Java permits DMotion, but only by explicit typecasting. For example, if you have int x equals int 3.0, that's valid. 3.0 is a double, you typecast it to an int, fine. Store 3 as x, okay? And in the case of typecasting by DMotion, once again, you just drop any decimal part. So anything that's above the range, that's beyond the range of the receiving variable is simply gone. On the other hand, int x equals 3.0, that's invalid because this is a double, and even though this is an integer, actually we could express int x, we could just assign it 3. The IDE is more careful than that. It says, nope, it just looks at the type. It doesn't look at the value. So it says, this 3.0, it is a double. If I convert a double to an int, I'm possibly going to lose some data, all of that decimal place data, or anything above 2 billion, above the range of an int. So I'm not going to let you do that. You have to actually specifically say, I want to typecast it, and then you'll force the way that the data is lost. This same logic applies to method returns. For example, my method here if this is an int, okay, this method has a return type int, I get the error there, but if I want to, I could typecast it and say, okay, that's fine, I'm getting an int. And then that's acceptable because 6.5 will be typecast to the int 6.0. I'll drop the decimal part. And since that's an int, then I can return it from that method. Okay, so again, unlike promotion you don't lose data because you're taking a numeric type that has a smaller range than the one you're casting it to, so you're not going to lose data, so Java doesn't worry too much. When you're doing DMotion, you're taking a variable with a larger range and compressing it into a smaller range. So you always have the risk of losing data. Because of that, Java says, I'm going to make you, the programmer, decide how the data will be lost. Okay, and this is a good break point, and we will come back and discuss this next time. Thank you for your attention.